Motherboards Part 3. In this nugget, we'll be talking about motherboards, and this will be Part 3. We're really primarily focusing on how to assemble a motherboard into the case and put the components in, and disassembly. Now, in terms of the assembly, this would be the case as if you had a new computer, for example, and you were building one from scratch. However, you may also be working on one of your own computers or a customer's computer where there's a problem with the motherboard and you need to take it out or upgrade it, and so you need to disassemble it first and then assemble it. So it just depends upon the context, but most of the tips are the same, just in reverse. The disassembly is usually the reverse of the assembly, for example. Then we'll also take a look at some installation tips that I'll have for you in terms of properly installing the motherboard. And then we'll talk about the diagnosis of the motherboard and repair. Quite honestly, for the diagnosis of the motherboard, there's not really a whole lot there because it's going to usually be a pretty catastrophic failure if there's a motherboard problem. Most of the time when we have a problem with the motherboard, we don't really repair it. We really just replace it. I probably should just replace that with replace, because there's really not much else you can do with the motherboard because it's not really a field replaceable unit. Have you ever had just a great day where it seemed like everything just fell into place and you had a wonderful experience of some kind? I recently did. You see, I received a text message from my mother-in-law. Yeah, you're kind of wondering, how in the world is this going to turn out to be a good day? But I received this text message from her, and she said that there was a beautiful rainbow near our house. So I took my tripod and my camera and the assortment of lenses, and I hopped on my bicycle, and I pedaled over to where I could get a good viewpoint of this rainbow, and here's the photograph that I took. So this turned out to be a really good day, and circumstances came up just right. My mother-in-law helped. In fact, I've recently printed this and framed it for her as a thank you. But, you know, you're going to have good days and bad days. Certainly, when you work with a motherboard, those can be horrible days, because if you don't set things up just right, there's only a couple of things that you can do wrong where you might prevent the computer from booting properly, or it might not even turn on at all if you make mistakes with the motherboard assembly. And of course, we don't actually put motherboards together. I'm talking about putting the motherboards inside the computer. So we're going to address that here, because if you do it properly, you're going to have a really gratifying experience where the computer turns on, you can install the operating system, and everything looks wonderful. Now, one of the ways that you can help to ensure that you have a good experience with the motherboard is that whether you're assembling one from scratch or whether you're disassembling one so that you can then replace somebody's PC, maybe their motherboard went bad for some reason, then you need to make sure that you take some precautions in advance. So, for example, if you're replacing someone's PC, and I say whole PC, but if you're replacing the motherboard, that's pretty much the same as replacing a big part of the PC itself, then one thing you want to make sure you do is to back up the data. Don't just assume that the user has all their data in the Documents folder or their My Documents folder, because there may be applications that have stored that in other locations instead. So they may not follow the standard Windows convention of storing things in My Document. One thing that you should do is, if you work in a shop, is that you have the user fill out a form identifying where all of their critical data is, so that you don't accidentally format the drive and lose all that data, or lose it in some other method, and then you're not able to restore it because you never knew in the first place where that important data was. So make sure that they identify that location, and also make sure that you can properly restore the data, especially if you're using a third-party backup software or something like that. I have had a customer that they backed up religiously to an external RAID array every night, but it turns out that when they needed the data, they found out that for technical reasons they were not able to restore the data. So it pretty much was the same as not having any data at all. Also, take a look at the CMOS settings. Now, there may not be a one-to-one correlation, because when you replace the motherboard, you're going to replace the BIOS and the CMOS settings as well. And you may want to make note of the old settings so that you can give the user, as close as you can, the same experience on their new motherboard. Now, you can't always do that, again, on a one-to-one setting, but at least try. Also, as I talked about in a previous nugget, make every precaution to protect the system against electrostatic discharge. And if you work in a shop, you probably already have a workbench that's ESD protected. Just remember to put on your heel strap or your wrist strap or whatever it is. And then also make sure that you disconnect all external connections to that computer. This would include the power and other things such as USB devices, external hard drives, keyboard, mouse, all those things. And I only say that because although it may seem fairly obvious, double check. Sometimes there will be things connected that are difficult to see, especially if it's underneath the desk or the computer's in a tucked away place, and then you think it's all disconnected and you pull it out and something is still connected in there. It could damage one of the ports, especially if you pull laterally. In fact, I'd done that myself to my own computer one time by accident. I had thought I had disconnected everything, and I pulled out the computer. It's on rollers because it's a really heavy machine, and I pulled out laterally, and one of the USB ports still had something plugged into it and cracked it, so it kind of messed it up. So just make sure that you learn from my mistakes. I did that to teach you people a lesson, so that you don't do the same thing I did. And then also just clear the way. Sometimes inside of the case, it's a real mess. Let's go ahead and take a look at an example of how that might look. So for example here, this is one of my own computers, and if I wanted to replace this motherboard, if I zoom in a little bit here, you'll see that there is a big mess and tangle of different kinds of cables and things all the way around. Could I zip tie this a little bit better? You can see I've got a zip tie here to try to help to manage that a little bit. But yeah, I could zip tie things a little bit better, but when it comes to removing the motherboard takes so much space. I mean, it's this whole area right here that it wouldn't really be possible to zip tie everything out of the way. Plus, a lot of these things are plugged into the motherboard anyway. So the main thing I'm trying to tell you here is you may need to tie some things off, maybe use a little clothespins or something like that to tie little cables and things over to the side so that you have a clear path for taking out the motherboard. Also, make sure that you take care of the expansion cards. Most of the time, if someone wants to replace a motherboard, well, they still want to use the same expansion cards in their new motherboard. In fact, I did just that. This was this was an older motherboard that I'd had. I had a couple of years, and I replaced the motherboard with a new one. That's the one I'm recording on right now, in fact. Well, the video cards were still good, so I took those out to put them into the new motherboard when I installed it inside the case. Just make sure that you take care of these as well, and what I recommend that you do is you still take those out carefully, protecting yourself from ESD again, and then place them inside of the ESD anti-static bags. Okay, usually you'll have a few of those laying around from previous projects or something like that, and just put it inside of the bag. Don't lay it on top of the bag because that doesn't actually protect it. You see, an ESD bag is designed so that if you touch it, static might discharge from you, but it's designed so that it will not penetrate through the bag and onto some of the sensitive electronic components. If you just put this on top of the bag, then you could still accidentally touch it and still damage something. Now also, when it comes to inserting the motherboard into the case, you do have to understand some things about the case, mostly just how you remove them. Now, most of them are fairly obvious, and it won't be too big of an issue. There might just be Phillips head screws, or you might need a nut driver to remove the screws off of the back of the case, especially if the user has assembled and disassembled the computer many times. If they didn't know what they were doing, they might have stripped out the head of a Phillips head, and plus a lot of those screws are not exactly the hardest of metal. It's kind of easy to twist out of those, especially if the user doesn't remember the old maxim of righty-tighty, lefty-loosey, because these are right-handed threads. In other words, you turn them right-wise in order to tighten them and left in order to loosen them. But anyway, that's usually not too big of an issue. The other thing you might have is you might have thumb screws back there instead, which I prefer. They're a little easier to grab a hold of. You can just use your hands and you don't have to use a tool. Or you may also have some that have some kind of a sliding lock. There's a bunch of different varieties out there. You'll just have to look for them. One of the cases that I've used in the past has a kind of an acrylic cover on it, and that's for the gamers so that they can see inside of it, and I guess you can show off all the components and everything like that. Boy, we don't have much of a life if we're trying to show off the components inside of our case. Anyway, one of the cases that I had two latches on it, and you may also need keys in order to open those up. They're round, circular types of keys that are used for this sort of thing. So just be aware of that. Also be aware of the fact that if the case door has a fan on it, well, of course, it's going to have to get power from somewhere. So there may be a lead there for the power to the fan. And likewise, when you put the case cover back on after you're all done, be sure that you do not pinch that power cord. That's very easy to do, and that could create a mess there. And you would want to short something out or have to patch together a severed cable, a power cable there. Also, when you work with these, again, I told you earlier, there's screws that you have to be aware of. Now, when you take a look at the actual motherboard and how you insert it, one of the things you'll first of all have to understand is a stand. And the standoffs that you'll need, it could go a couple of different ways. In this particular case, no pun intended, but in this literal case right here, we have these items. These are kind of little bumps that appear off the floor of the case. And then what you would do is when you install the motherboard, it rests right on top of this bump. The reason why you have to have this bump is so that it puts some distance between the bottom of the motherboard and the floor of the case right here, so that you can have some ventilation and free airflow that goes through there. You don't need a whole lot. Most of the heated components are on top of the motherboard, but underneath it, you'd still want some ventilation there. So in this particular motherboard, the standoff, if you will, is already included, but there are certain other types that you should be aware of here as well, and more likely you're going to see something like this, if I can find it. Let me see, right there. Okay, that's a brass standoff. In this particular case, we have, it's a little brass piece that you screw down into a hole in the case, and this one, notice, is a flat floor here. This whole case floor is flat. It doesn't have little bumps on it. So then what we would do is we would screw our motherboard screws through the motherboard and into this standoff that we see here. That's what those threads are that you see here. Then when you actually look at the motherboard itself, and I'm looking at just one portion of it right here, you can see the screw hole right here where we would take our screw and plop it down in there. And then underneath this, down at the bottom of this, would be the brass standoff that would be threaded for this screw. Then what we would do is you would just take the screw and you would screw it in. Not too hard to figure out. Just, righty-tighty, righty-tighty, lefty-loosey. Okay, and that's pretty much it. And then you can see here that you can use a nut driver because it's an octagonal shape, or a Phillips head screwdriver. Now, the other thing to keep in mind with this is, both with the brass standoffs, if you use those, and this screw that we're looking at right here, you only want to tighten those pretty much finger tight. Don't try to show off all your muscles and really totally torque those things down, because especially with these that screw into the motherboard, if you tighten them too tight, you wouldn't want to crack any of this substrate right here, this material, and put any fractures in it. Now, that's a little unlikely because it's a fiberglass material and it's layered with various types of coatings and things like that. But nevertheless, you can see how close this is to certain electrical pathways, for lack of a better word, circuits and the like, and you wouldn't want to take the risk of damaging any of that. So again, just finger tight, which means that you don't tighten your whole fist around it and lean all your weight into it and squeeze it and turn it as hard as you possibly can. Just fingertip tight is usually fine, and you want to just snug it down. And then you'll also want to map out where those screw holes are. And normally on an AT-style motherboard, or rather an ATX-style motherboard, they'll pretty well be lined up in a kind of a default configuration here. But what I want to show you here is that we have a few here along the side, some down here as well. 1, 2, 3 that we go over here. And then we have a couple, 3 back here. Okay, they're not necessarily all in a straight line, because notice that these two don't line up because you got to make room for these ports. But the thing I'm trying to show you here, if I can push in a little bit further, is that sometimes you'll have holes that aren't really holes. For example, this one, and you can kind of tell because it's got metal all around it here. That's where the screw rests down on it, and it kind of grounds it. That's where I'm going to put a screw in. Here, there is a hole here, but it's not for purposes of screwing the motherboard down. Most cases will not have a screw hole where you can put a standoff or anything underneath there anyway, but just in case, don't try it, just because you wouldn't want to, again, damage this material by trying to screw down a screw on there. Also, when you screw these in, this is just as a matter of experience, I'll share this with you. This is one of the places where screws can get lost. You generally try to avoid using magnetic screwdrivers. That's kind of a general rule of thumb. And it used to be because magnetism could adversely affect floppy disk drives, or floppy disks, or or floppy disk drives. But really, you'd have to have a lot of magnetism to be able to do that. And so most magnetic screwdrivers, in my opinion, this is not an official A+ statement, but in my opinion, are reasonably safe, as long as you're cautious with it. So that will help me to lose fewer screws because of magnetic screwdriver tips. However, if you do lose one, a lot of times those can get lost in between the spacer and the bottom of the motherboard, and might be rattling around inside the case. Do your best to retrieve those, because they could create a short depending on how they rattle around in there. So just be cautious of it. And then switching over to this photograph, I just took a picture of the inside of a brand new case where the vendor has taped down a bag of screws of various types. And you can see here's the standoff, that's the brass standoff, and then this would be one of the screws that we saw that was screwed into the motherboard. And then they may also provide other screws for like the hard drive cages and things like this. And then here's was the keys that I was mentioning earlier, the round keys that you might get to lock down the case. Well, these are the kinds of keys that you might see for that. And then, of course, a lot of times they'll come with this silica gel, which is very useful for absorbing moisture, and you're supposed to throw these things away, but I actually keep them because I put them in, camping gear and my camera gear and stuff like that, just in case I get caught in the rain. It's not going to absorb all of the rain, but it will absorb a little bit of moisture, and you might have some other purposes for those as well. And then you may also see certain types of proprietary connectors here as well. I think if I show you this picture, there's one in that picture that I just showed you. So let's go back to this. Yeah, there's one right there. So if I kind of zoom in over here, it's not a very good angle because we're looking straight down on it. But you may see holes in the motherboard where it's very similar to this one right here that you're not supposed to put a screw in. But on the case, there might be a plastic piece like this that I just showed you right here that pokes up through that hole, and it's kind of like one of those picture hanging bolts that you put through drywall. As soon as you put it through the other side, it kind of springs out and allows you to, put some tension on it and hang a picture on it or something. This is the same thing. There might be, a couple of sides of this that spring out when it pops up through this hole. And then in order to remove this motherboard, or then you would have to take some needle nose pliers and squeeze this back together to make it small enough to fit back through that hole. So you may see that type of a connector here from time to time as well. And then I think I mentioned this earlier as well, but the panel connectors, when we talked about that, when we examined the motherboard, and I showed you some close-ups of all of that, let's just go ahead and review that real quick. When you take a look at those panel connectors, remember, this might be connected in a certain order. I've also seen some cases, these are really horrible, where they're not marked. And so you can't really tell whether this is for the power or it's the reset switch or it's some kind of an internal speaker or whatever. So it might take a little bit of guesswork. Fortunately, we don't see that very often anymore because of standardization. But what I would do is I would make note of the order in which these things are all connected, and you might just take a little bit of tape or something and mark all of those. One thing that I've been doing a lot in the past few years is I just take my cell phone camera and I'll take a picture of it, so that might help there as well. And hopefully you'll have these case connectors that are at least marked like this to make things a little bit easier. One other thing, that, by the way, when you connect these is that people sometimes ask, which way do they go? Because there's not really a keying on here so that you're forced to put it in one way. Well, normally what's going to happen with these is you'll put these so that the wording is out. Okay, so that the wording is visible. Not all of them, like in fact the picture you just saw is a good example of that, but much of the time you'll put these so that the wording is out. And with these particular items, it sometimes doesn't matter. It just needs to, because all that happens is when you, for example, hit the, the power switch. Notice for this one, there's only 2 leads into this. And all that happens is when you hit the power switch is it shorts these 2. So it wouldn't really matter for something like this, but if you need to double check, just again, you might take your cell phone out and snap a picture of it, or otherwise mark these connections. And then as we get back to our whiteboard here, one other thing you might want to look at, and again, some of this that I'm talking about is in the context of replacing a motherboard. You might want to check the drive order connections. So, for example, especially if it is the same vendor of a motherboard, you're not completely swapping out everything. In other words, you're not swapping out an Intel motherboard for an AMD, and the motherboard manufacturers an Asus, whereas before you had a Gigabyte brand motherboard. If it's pretty well across the board equivalent, just something was wrong with the other one, and now you're putting in a replacement, for example, then you might want to also check the drive order connections. Now, what's supposed to happen here is that if you have something like a RAID array, and a lot of even consumer motherboards right now will have these things, and we took a look at this earlier, then this could be set up in RAID. So, for example, if it was RAID 5 and I was using these 4 drives, you need at least 3, but let's say I was using these 4 drives. This would be the first drive, this would be the second drive, this would be the third one, and then this would be the fourth one, and then maybe this would be a CD or a DVD or something over here. But what's supposed to happen with many of these is that if you replace the motherboard, or if you were just for some other reason to disconnect all of these on a perfectly good working motherboard, then for many vendors, you can plug these back in any order, and it will be intelligent enough to identify which drive is which, and it will arrange them appropriately, and you don't lose any data or anything. But there is some risk that the vendor will require these in a specific order. So in other words, the hard drive that was plugged in here has to go here. It can't get plugged in over here, or else the data will not be readable or something like this. So do try to make a note as well of which ones these are plugged into, although most of the time you'll probably be okay, even if you mix them up. Now then, do also make sure that you completely disconnect the power before you even get started. That probably should be a bullet point that I put earlier in this whole process. But do disconnect the power entirely. It's not just enough for the computer to be turned off, because the motherboard will still draw power. In fact, on a lot of the more current motherboards, you'll look at it, there will be LEDs lit up and things like this, and sometimes those are for diagnostic purposes or for informational purposes, but it's just proof that indeed there is power still flowing through that motherboard, which could further exacerbate the possibility of electrostatic discharge as well. And then, as I mentioned earlier, a lot of times it's easy to get mixed up with what went where, especially if you're doing a replacement of the motherboard, or if you need to replace the order in which things were plugged in the back of the computer, especially with USB ports, because there can be a lot of different USB ports, and you might want to keep the order the same. Then you can use your cell phone camera. Very often that works well. It works especially well if your cell phone camera also has a little flash on it. Not all of them do, but especially in the darker places of these cases, might make it a little bit easier. Just so that you can keep track of things like this, where if you had different items plugged into different places, then you would know a little bit more about where things were supposed to go. Oops, didn't mean to draw across that. But you might know which went into these ports right here and so forth. Also, we didn't talk about it a lot, but over here, this is something that we're starting to see less and less of these days. But here's a PS2 port for the mouse. The mouse is always green. And this is the PS2 port for the keyboard, and the keyboard is always purple. And you can see here that there are 6-pin connectors in there. Let me zoom in a little bit here. Bring that into our view a little bit better. I think I can. There we go. Then you can see that there's 6-pin connectors in there, and it has a unique shape that it's keyed so that it will only go in one way. And then there's a little notch here as well. So you can only really plug it in one way. And most modern keyboards and mice are also color-coded accordingly so that you don't mix these two up. I remember originally how they were all just kind of that office beige color, and you never really know which one was which, and sometimes they weren't clearly marked, but now it's much better these days. And then when it comes to the actual installation, there are a few tips that I can provide for you here as well. Number one, do lay the case down flat so that you can use gravity to work with you as you screw in the motherboard into the screw holes. And the reason for this is because if for some reason you were trying to do it where the case was upright, for example in a tower configuration, then the motherboard could constantly slip while you're trying to install it. It just makes some common sense to lay it flat. Now there may be some rare situations in which you're in a physical limitation where you cannot do that, and you may have to do it while it's upright. Again, that's kind of rare, but if at all possible, lay it flat. Also, tighten the screw holes diagonally. This makes a lot of sense in a lot of household repairs or whatever else it is where you're trying to install something. Now, here's my motherboard, and I've got screw holes roughly in the corners, and then we also have some, somewhere in the middle here, something like that. So what we'll generally do is we'll put a screw hole in one of the easily accessible screw holes, and beneath the motherboard, of course, is your standoff. So we'll screw one of these down and not torque it all the way down, because we may need to shift this motherboard one direction or the other so that we can line up these screw holes for the other screw holes. So once it's not all the way tightened down, but it's holding the motherboard in place, and then you can shift this up or down as necessary to line up this screw hole. Then you can put your screw hole in there. Once you have this one properly lined up, you can usually tighten that one down finger tight, and then you can, once that's been done, you can also snug this one down, and then check your other holes to make sure that they're still lined up properly. They should be, using this method. And then you can finger tight all of these, mostly in any order, but you want to at least start with a diagonal so you have an axis to work off so you can line up the holes there. And then also do test fit the motherboard in the case. If you're using ATX motherboards, which most of them are, and you're using ATX cases, which again, most of those are now ATX, then everything should be industry standard and it should line up just fine. But you have other things that the case manufacturer and the motherboard manufacturer might not have accounted for. For example, the size of the power supply, other devices that you may have in there, other cables and things like this. So just test fit it to make sure that you can at least get it all in there. And also, do especially test fit the I/O shield. So for example, popping over here to this photograph, you can see that in the I/O shield, some of them are kind of cheap, but they have kind of a little bevel around the edge of them, and they pop through the opening in the case, and this should be an exact fit. ATX case, ATX motherboard, the shield usually comes with a motherboard, and it should fit in just perfectly here. And then it should line up with whatever your components of the motherboard are. Okay, so if it has, for example, these two serial ports down here at the bottom, that's what these are, serial ports, then there should be an opening for that in the I/O. There should be an opening here for this, parallel port. And then over here we have actually a gaming port. You don't really see these much anymore because this is for like a joystick over here to the right. There we go. Nowadays, most of these joysticks are on USB ports instead. But anyway, when you do that, you'll notice that, and here's a top-down view of the same kind of a thing. Notice that in the I/O shield, look at these prongs that are sticking out right here. What these are is they're going to put some tension on the counterpart. For example, tension on the counterpart for a parallel port over here or whatever, and it just helps to line things up properly. It's good to have a little bit of tension on there. Hey, look, there's my fingerprint on top of this thing. I don't know if you can see that. There's my fingerprint. Someone's going to probably steal my identity now based on that. Anyhow, the reason why I bring up the issue of these I/O shields is because these things, especially the cheaper ones, can be really a little bit of a hassle. If you just slightly get this off axis a little bit, or you get these a little twisted or out of the proper alignment, these things can get all bent up and messed up. You can fix it. They're easy. You just got to use some needle nose pliers, or even your fingers can probably bend these back in place. But a lot of the I/O shields now, especially from Asus, which is the motherboards that I've been buying lately, will have this whole I/O shield. It'll be kind of a padded foil item. There's like a padding under here, and it's much easier to line up, and it's much more forgiving. I don't have to worry about bending prongs back and forth and all that kind of stuff. But just test fit this carefully before you go around jostling too much there. And then finally, when it comes to motherboards, in diagnosing problems with the motherboard and repairing motherboards. In terms of the diagnosis, you're generally going to find that you can narrow things down to the motherboard when it can't be anything else. For example, if you have video cards, but you're not getting any video signal, you would, of course, check your video cards. So that seems fairly obvious. If you're getting a hard drive failure, of course, you're going to check your hard drive failure, your hard drives to see if they're failing. So normally, in terms of troubleshooting, you will go to whatever is showing problems first. The motherboard is so all-encompassing that if it starts to fail, it may actually be a little bit difficult. So it's going to be also very disruptive. Because if you do have a problem with the motherboard, it could affect every other aspect of that computer. And very often, this will be a motherboard that will not start. You will not even be able to power it on. If it's had some ESD damage to it and someone's touched one of the chips on the motherboard, then it might also not start. Or it may start suddenly blue screening you. This is a Windows phenomenon where you'll get what we call the blue screen of death, and it'll just show a bunch of hex codes up there and everything, and it's very disruptive. Blue screens can also be attributed to a lot of other problems, but if you do have a motherboard problem, that might be one of the causes there as well. Nevertheless, if you determine that it's an overall or kind of a catastrophic failure and it's not isolated to a specific component of the computer, you may need to look into whether or not it is the motherboard. Now, with most other components, they're simple and easy to exchange and to replace. For example, if I can't get my modem to work, I'll just take another $15 modem out of the drawer and stick it in there and see if it'll work. However, the motherboard, again, is highly disruptive, much more expensive, and so you really don't want to try to do that unless you've already ruled out everything else. And we'll talk more about troubleshooting things later on the whole. But when you do replace the motherboard, if it truly was the motherboard that was the problem in the first place, and if it's the same exact brand and vendor, then you should see the system come back up just fine. Now, the other thing you might see, well, I want to point out rather, is that the motherboards rarely fail on their own. Other things can fail on their own. For example, a lot of video cards nowadays have cooling fans directly built onto them. Well, those cooling fans might wear out or might start to make strange noises or something like this. So you may have to replace the entire video card. It could be other things like hard drives, which are the most mechanical device, usually, of your entire computer. Those fail. Okay, so you'll have to replace those every now and then. But motherboards, there's really very few, if any, moving parts. Some of them will have a little fan here and there, which is sometimes even replaceable. But they rarely fail on their own. Again, the culprit is going to be damage. Whoops, that's supposed to be an A. Damage. Or some kind of ESD, which is another form of damage, actually. But someone may have dropped something in there when they're trying to replace a component or something like that to damage the motherboard, but they don't usually fail on their own. Now, if the motherboard does fail, really the only solution is to replace it. The only thing I can think of that might be somewhat replaceable, if you can get one from the vendor, the motherboard manufacturer, is the BIOS and the CMOS. So that's all on a chip. On the CMOS. And if you have a chip puller, which is a specialized kind of tool we don't really see around much anymore because nobody really uses them anymore because you don't do this very often. Well, you could pull that out and replace that one from the vendor, but very often you're not even going to be able to do that anymore. So if the motherboard has a problem, you just replace it. On the whole, it's mostly not a field replaceable unit or a FRU. And by the way, I would know that acronym, field replaceable unit. Other examples of field replaceable units would be a hard drive, a video card, a modem, any other kind of an expansion slot device, a memory module. Those types of things are things that you can just go down to the store, buy another one, and replace it. Whereas the motherboard on the whole is generally not considered a FRU. In this nugget, we talked about motherboards, and this was part 3, where we started by primarily talking about the assembly of the motherboard into the case, or disassembly, just kind of reverse of one another. And this would be context sensitive depending upon whether you're building something new from scratch, for example, or replacing or upgrading a motherboard entirely. First, you have to disassemble what's already there, and then you would assemble it. And then we talk about doing that. We also talk about some installation tips to make sure that the project goes as smoothly as possible. And then we talk also about diagnosing the motherboard. Normally, a motherboard problem is going to be pretty catastrophic, and very often the system won't even start if there's an overall motherboard problem. Very often, it's actually going to be one of the other components that you're having problems with. But if it is the motherboard that turns out to be the problem, there's really no repair there. There's really no repair. Really, you just wind up replacing the motherboard. So just keep that in mind. It's a little bit expensive because motherboards can be quite pricey, especially if it's a high-end, overclocker's motherboard or something like that. But there's usually nothing you can do to the motherboard to repair it directly. Well, I hope this has been informative for you, and I'd like to thank you for viewing.